Hello students, good morning. My name is Dr. Mallikarjun, working in Institute of Aeronautical Engineering in the Department of Information Technology. In the series of lectures on operating system, today we will discuss the Convoy Effect. So Convoy Effect is the problem which we seen in the process scheduling algorithm, first come first serve scheduling algorithm. See, what is Convoy Effect? The Convoy Effect in operating system refers to a situation where a long-running or resource-intensive process blocks or delays other process, causing a performance bottleneck. The effect is primarily associated with the first-come, first-serve scheduling algorithm, where the processes are executed order they arrive, regardless of their processing time. See, in first come first serve in process scheduling algorithms, there are two situations. One is preemptive scheduling and non-preemptive scheduling. Preemptive means once process submitted to the CPU, it can switch to other process while running. That is preemptive. See, preempt a running process to allocate CPU to another process, typically based on priority or time sharing policies. Mainly, a process is switched from the running state to ready state. See, preemptive scheduling algorithms are round robin, shortest remaining time fast. So there are very many preemptive algorithms. Non-preemptive means it can't switch once process submitting to CPU. It can complete their execution, then next process can submit to the CPU. That is non-preemptive. Cannot interrupt the process in the execution in the operating system. It is voluntarily relinquishes control of the CPU. The process holds the CPU till it gets terminated or reaches a waiting state. Non-preemptive schedulings are first come first serve scheduling, completely non-preemptive scheduling. In the non-preemptive scheduling, we seen the problem of the convoy effect. See how convoy effect affects, we will see in the problem. Okay, let's see the problem. There are three processes P1, P2, P3. In this three process P1, P2, P3, their arrival times are 0, 1, 1. Their burst times are 20, 2, 1. So this convoy effect comes under the non-preemptive scheduling, which is a non-preemptive scheduling. See, in the non-preemptive scheduling, once process submit to CPU, it can't switch until completion of that process. See, let me check where in the Gantt chart. Let me check this problem in the Gantt chart at zeroth interval of time. So process P1 comes and their burst time is 20 units of time for their execution. 20. So next, zeroth interval of time P1 comes. At first interval of time, P2 comes into CPU and P3 also come into CPU. Both P2 and P3 both are coming to CPU. At P2 starts in the running position and then execute 2 units of time. It takes 22 units of time. It's completed. Then P3 comes. It executes time 22 plus 3, 22 plus 1. Their execute time. Their burst time 22 plus 1. It takes 23 units of time. Okay, their completion time, once you notice that P1 completed at 20 units of time, P2 completed at 22 units of time, P3 completed at 23 units of time. completion time. So then we compute as the turnaround time. Turnaround time is TAT, that is equal to completion time minus arrival time. That is 20 minus 0, 21, 22 minus 1, 21, 23 minus 1, 22 is the turnaround time. Then waiting time is equal to turnaround time minus burst time. Okay, then we calculate the waiting time here. Turnaround time minus burst time, 0, 21 minus 2, 19, 22 minus 1, 21. So we calculated waiting time here. Then average waiting time, then we calculated as 0 plus 19 plus 21, 0 plus 19 plus 21 by 3, that is equal to 19 plus 21, 10, 21, 19, that is equal to 19, 1, 10, 2, 4, 40 by 3. That is equal to 13.3333 is the average waiting time. Okay, we'll see the same problem. If you change the arrival time, what will see the average waiting time? See, this is the same problem. This is the same problem. So here process P1, P2, P3, their arrival times 0, 1, 1, their burst time 20, 2, 1. In the same problem here, P1, P2, P3, their arrival times are changed here. 1, 0, 0 and burst times are 20, 2, 1. So same problem but changing the arrival time here as per the previous problem. Then we calculate the average waiting time. Under the non-preemptive scheduling. Let me work this problem under the non-preemptive scheduling. So let me take a Gantt chart. At 0th interval of time, no process could not come. No. 0th interval of time, P2 and P3 both are come. So chance got to the first P2, then it executing the 2 units of their burst time. So P2, 2 units of burst time, P2 is completed their execution. Then 2 units of time, P3 also there in the queue. So P3 come and execute the 3 units of time. That burst time is 1 unit. It execute the 3 units of time. Now P1 comes at the end. So they execute 20 units of time. So totally 23 their completion time. Then we calculate the completion time. So completion time, P1 completed at 23 units of time, P2 completed at 2 units of time, P3 completed at 3 units of time. Now we calculate the turnaround time. Turnaround time is completion time minus arrival time. So completion time 23 minus 1, 22. P1 completion time, P1 turnaround time is 22. P2 turnaround time is 2. P3 turnaround time is 3. Then waiting time. waiting time is turnaround time. Waiting time you calculate turnaround time minus burst time. Turnaround time minus burst time. Turnaround time 22 minus 22 waiting time. 2 minus 2 0. 3 minus 1 2. Then we calculate the average waiting time. So 2 plus 2, 2 plus 0 plus 2 by 3. That is equal to 4 by 3. That is equal to 1.333333. So here we calculate, here we got the average waiting time 1.333. In previous problem also same problem, we got average waiting time. Here we got average waiting time 13.333. So almost here 1.33 in the same problem, we got here 13.333. So this is the convoy effect. See, convoy effect means we worked out the same problem. You change the arrival time, that almost all average waiting time is totally different. So this is the convoy effect, means a process executing a long time, a largest process executing a long time, remaining process should wait. If remaining process is important process, so it wait until completion of that long process. So this process affect the remaining process should wait until completion of the given executing process. So convoy effect in operating system is a situation where a long running or resource intensive process blocks or delays other process. This is a bottleneck. So convoy effect, we seen the bottleneck, the same problem we seen here. Here average waiting 13.33. When you change the arrival time here, instead of 0 to this, we change the arrival time here, instead of 0 to 1 and 0 0, we can get the 1.33. We can get the 1.33 arrival time. See, so this is the bottleneck. A longest process executing the long time. So the remaining things we same, calculating the burst time, arrival time, waiting time, turnaround time and completion time. So that is the problem of the convoy effect. See, this convoy effect we seen in the situation in the first come first serve problem. Actually, this is the situation in United States, where as the president comes, in the remaining all traffic should be stopped until the convoy, means the vehicle of president gone in the road. Remaining all vehicles should wait until the president has gone to the road. After president went, remaining that roads, the vehicles are gone. So this is the convoy effect, means the same word has taken by the author and written the this and situation mentioned here. This is the problem affect the convoy effect in the first come first serve scheduling algorithm. See, remaining words are same: arrival time AT, burst time BT, completion time CT, waiting time WT, turnaround time TAT. Arrival time is when a process enters the ready queue, that is called arrival time. Burst time is the time process needs to execute on the CPU. Completion time is when a process finishes its execution. Waiting time is the time a process spends waiting in the ready queue. Turnaround time is the total time from arrival to completion. So this is the problem we seen in the first come first serve, in the problem of the convoy effect. So we don't want convoy effect. So we eliminate the convoy effect. That's why first come first serve scheduling algorithm is failure. Then that remaining algorithm should going to be invented. Those algorithms are shortest job first, round robin, priority scheduling algorithms. These are invented. So this is the main disadvantage of the first come first serve algorithm. So as we seen convoy effect, the same problem, when you change the one problem we solved, we got 13.33 as a average waiting time. The same problem, when you change the arrival time, we got 1.33. See the difference. We got one problem, the same problem 13.33. the same problem we execute, change the arrival time, we got 1.33. Almost waiting time, 12 units of time is difference. So 12 units of time is very important in the process in the executing. So this situation is called convoy effect. So that's why first come first serve scheduling algorithm is failure because of the convoy effect. So we don't want the convoy effect. See, we collected this information as following with the references books, Abraham, Silbersage, Peter, Galvin in the Operating System Principles title book. This Wiley student publisher, 8th edition, 2010. Another book, we collected the information from William Stallings, title of the book, Operating System, Internals and Design Principles. This publisher, Pearson Education, and 6th edition, 2002 publisher. We got the information of the convoy effect. Okay, we've seen the remaining process scheduling algorithms in coming videos. Thank you, students.
Like, share and subscribe. Hit the bell icon for more updates.